before going to the detail of the GQ system, or you can say the IP3-DAG pathway. So what is GQ system? What is IP3-DAG pathway? So before going to the detail of this IP3-DAG pathway, I am telling before about the previous classes and about the GA system or GI system. So previously I talked about the receptor is divided into classified into extracellular receptor or intracellular receptor. In the previous video you can see about the whole of the classification of the receptor. So you can classify the receptor into two parts, extracellular receptor or intracellular receptor. So those molecules whose molecular weight is very high or they cannot enter through the cell membrane, so their receptors will be expressed on the surface of the cell. So extracellular receptor. Now those molecules whose molecular size is very small and they can easily enter through the cell membrane, so their receptors will be expressed within the cell. So this is the intracellular receptor. Now we classified about the which type of receptor will express on the cell surface. So I taught to you in the previous videos that the one of the type of the extracellular receptor is the 7-pass receptor. 7-pass receptor, and the another name of the 7-pass receptor is the G protein coupled receptor, or you can say the GPCR. So we already discussed about the 7-pass receptor and GA system and GI system. So what is 7-pass receptor? The another name of the 7-pass receptor is the G protein coupled receptor, and you can say the serpentine receptor because it's the serpentine look like a snake. So 7-pass receptor, you can also say that this is also named as GPCR and serpentine receptor. So now we will talk about the GQ system. So GQ system, what is GQ system? The another name of GQ system is the IP3-DAG pathway. So what is the IP3-DAG pathway? So let's see here. So this is the GQ system. Previously I talked about the GS and GI system. Now this is the third type of the system is known as GQ system. Now GQ system having a cell surface receptor. Okay, this is look like this, and now suppose we are taking a smooth cells. Right. This is the smooth cell. Okay. Now the drug, suppose that norepinephrine or epinephrine will come and bind to this receptor. Okay. This is the drug. Drug will come and bind to the receptor, a specific type of receptor. So epinephrine, norepinephrine will come and bind to this receptor. Okay. Now what will do? This drug, after binding to this receptor, this will stimulate the effector binding domain sites, as I said in previous videos. Okay, this after stimulation of this effector binding domain, this will stimulate the trimeric protein known as G protein. Okay, previously I talked about the G protein is the trimeric protein containing the alpha, beta and gamma. Okay, basically alpha subunits containing the GDP in the initial stage when no any drugs is bind to this receptor. When there is no any drugs, then alpha subunits containing GDP in the ground state. Okay. Now drug will come and bind to this receptor. Now this will stimulate, the peptides will stimulate. Basically this is the 7-pass, the another type of the 7-pass receptor. This is 1, 2, 3, 4, 5, 6, 7. Okay. Now this is GQ system. GQ system is a 7-pass receptor, the another family of the 7-pass receptor. So basically this is the IP3-DAG pathway when the drug will come and bind to the receptor binding domain site, this will stimulate through the peptidal chain, and it will stimulate the further stimulation of the effector binding domain site. Okay. Now, after stimulation of the effector binding domain site, this will stimulate the trimeric protein, G protein, and basically alpha subunit containing the GDP. So, after stimulation of the G protein, the GDP will refuse. GDP will refuse, and who will acquire? GTP will acquire. Good. GTP will acquire. So GTP will acquire and GDP will refuse. So after acquisition of the GDP, so alpha subunit will stimulate. Means after acquire the GDP, means after acquiring the GDP, this alpha subunits will get some energy, and after getting some energy, they will produce some unstability. So this stimulation of the alpha unit, this alpha subunit, this will refuse the beta and gamma. After stimulation of the alpha subunit, this alpha subunit refuses the beta and gamma and dissociated from the trimeric protein, dissociated from the beta and gamma, and it is responsible. This is the alpha subunit attached with GTP. Okay. Now, alpha subunit containing GTP will stimulate the one of the protein or one of the membranous protein known as phosphorylation C enzyme. Okay. So these alpha subunits, the stimulated alpha subunits containing GTP will stimulate the membranous enzyme, protein enzyme known as phosphorylation C. So what will do the phospholipase C? Phospholipase C having a seizuring property. So now this phospholipase C will cut down the membranous protein. This phospholipase C will cut down the membranous protein known as PIP2. What is the full form of PIP2?
Phosphoinositol
diphosphate. Good. So phosphoinositol diphosphate. Okay. Now this membranous protein will, after cutting this membranous protein, this will change into the two secondary messenger known as IP3 and DAG. That's why this is also known as GQ system is also known as IP3-DAG pathway. Okay, so this is the byproduct of the PIP2 membranous protein phosphoinositol diphosphate will convert this two byproduct, that is the inositol triphosphate and diacyl glycerol. Okay, now what the IP3 will do? This IP3 will go to the sarcoplasmic reticulum, which is the hub of the calcium. Okay, the storage of the calcium. So this IP3 will go to the sarcoplasmic reticulum membrane, which will activate the pump related to the calcium channel. So it will be responsible to open the calcium channel pump. Now all of the calcium will move from the sarcoplasmic reticulums to the cytoplasm. Okay. Now this calcium, after moving from sarcoplasmic reticulum to the cytoplasm, they will come and bind to the specific type of the protein known as modulin protein. Okay. Now calcium will bind to the calmodulin protein and forms the calmodulin proteins. Okay. Now this will form a complex. Now calmodulin complex. Calmodulin complex will act on the calmodulin kinase enzyme, isn't it? So calmodulin complex will act on the calmodulin kinase enzymes, and what the kinase will do? This is responsible for the phosphorylation. Okay. In previous videos, I also tell about the phosphorylation and all this in the GS and GI system. which I will add in this video link. Okay, so previous 2 videos link I will add with this video. Okay, so you can see from this link. Okay, now so this calmodulin kinase enzyme, after stimulation of the calmodulin kinase enzymes, this will phosphorylate the enzyme. Okay, and it will be responsible for the alteration of the metabolism. Now it will also be responsible to phosphorylate the transcriptional factor and it will be responsible to alter the genetic expression. So what is the genetic expression changes? The transcriptional changes, the translational changes. It will form the protein, new formation of the protein, है ना? So and another work of chem kinase is to act on the ion channel. When it will act on the ion channel, suppose this is the calcium channel, so now extracellular calcium is higher with comparison with the intracellular. So high quantity of the cellular according to the diffusion law, so high concentration of the calcium will move from the inside, low concentration of the calcium. Okay, so it will move from the outside the cells, from the outside to the inside. Okay, now calcium is responsible for the contraction of the muscles. So this is smooth cells or smooth cells associated with the muscle will contract. Okay, due to the effect of the calcium. Now the another part of this system is the DAG. What the DAG will do? So diacylglycerol, the another secondary messenger of the IP3-DAG pathway or GQ system. So the diacylglycerol will do to act or stimulates to the phosphokinase C enzyme. So what the diacylglycerol will do? So diacylglycerol will stimulate the phosphokinase C enzymes, which is responsible for the again phosphorylation of the enzyme, and it will after the phosphorylation the enzyme will alter the metabolism. After the phosphorylation of the enzyme, this will be responsible to alter the metabolism, and this phosphokinase is responsible for the phosphorylation of the transcriptional factor, and this is responsible for the alteration of the genomic expression. And now the third action is it will act on the potassium channel. Now the concept will come here. The potassium channel, that means the potassium, where is the potassium ion is more in the concentration, the inside or outside? Inside is more. That's good. So inside the intracellular, the potassium ions is more, so it will move from the inside to outside. That means the positive ion will less in the cell. So this will go to the hyperpolarization. Okay, the concept will come, hyperpolarization will take place here, because positive ions will move from the inside to outside. That means the negative potential will activate, and when the negative potential will activate in the cell, that means this will come for the firstly will achieve the polarization state, then it will go to the hyperpolarization state, isn't it or not? When the calcium will move from the outside to inside, that means the positive potential will improve, that means the stimulation will take place. The stimulation, how stimulation will take place? When the calcium will move from the inside to outside to inside, then the contraction will occur, that means that this is the outcomes of the stimulation. And when the positive ion will move from inside to outside, that means the calmness will come, because due to the hyperpolarization, because our cells is going to be negative potential. Now I am repeating all these things. So GQ system, today I talk about the GQ system. What is the GQ system? Then another name of the GQ system is the IP3-DAG pathway. What is IP3-DAG pathway? IP3 is the inositol triphosphate and DAG is the diacyl glycerol. So this is the pathway because the IP3 and DAG will form in this system as a secondary messenger. That's why this is known as the IP3-DAG pathway. Now, what is the IP3-DAG pathway? This is a family of the 7-pass receptor. As you know, the G protein coupled receptor. That means this is receptor associated with the 7 peptidal cross membrane receptor having the effector binding domain sites attached with the G protein, which is associated with the trimeric protein alpha, beta and gamma. Now, suppose this is a smooth cells. Now we taking the smooth cells. A drug, norepinephrine, epinephrine will come and bind to the specific binding domain site. Now after the binding, this will stimulate the peptidal chain and the stimulation of the effector binding domain. After stimulation, this will stimulate the G protein. Basically, when the drug is not present in the binding domain site, then the alpha subunits of the G protein will bind to the GDP. When drug will come and bind to this receptor, then G protein will stimulate. Or after stimulation, the alpha subunit containing the GDP will refuse and GDP will acquire. That means the alpha subunit gets some energy. Means GDP. Previously it was the GDP and now it is in the position of the high energy. So alpha subunit gets some much more money. So this is the three friends, alpha, beta and gamma. This is the three friends, alpha, beta and gamma. Now alpha subunit is having the much more money. So this behaves like a different attitude from the situation. Okay. So alpha subunits become a rich. So how rich person is behaves? You know about that. So this alpha subunit will kick out the beta and gamma, and this will dissociated from the beta and gamma, two friends beta and gamma. Now alpha subunit rich persons will go and bind to contact with the rich personality, that is the phosphorylation C. Okay, mediocre person. So this will alpha subunits will come and bind to the phospholipase C, and this phospholipase C will stimulate or having the seizure properties to cut down the membranous protein phosphoinositol diphosphate. Now, after the cutting of the membranous protein phosphoinositol diphosphate, this will change into the IP3 and DAG. This is the secondary messenger. So, what the IP3-DAG will do? So, IP3 will go to the sarcoplasmic reticulum. This will activate the calcium pump. All of the calcium will move from the sarcoplasmic reticulum to the cytoplasm, and this calcium will bind to the calmodulin protein, will make the complex that is known as calcium calmodulin complex. Will make a complex known as calcium calmodulin complex. Now, this calcium calmodulin complex will stimulate one of the kinase enzyme known as calcium calmodulin kinase. Now, what the kinase will do? Every time I told to you that the kinase is responsible for the phosphorylation. So, CAM kinase will phosphorylate the enzyme and it will be responsible for the alter of the metabolism. Now, is this CAM kinase is responsible for the alteration in the transcriptional factor and it will responsible for the alteration of the genomic expression in terms of the transcription, in terms of the translation. Now, it will also phosphorylate the ion channel, and this calcium ion channel will, the calcium outside of the cells is more in the concentration, so higher concentration move from the higher concentration to the lower concentration. So extracellular calcium ion will move from this channel from the outside to inside, and calcium is responsible for the contraction of the heart muscle, because norepinephrine you are using, and norepinephrine is used for the activation of the sympathetic nervous system. When the sympathetic nervous system will activate, that means heart rate will increase. How the heart rate will increase? Because of calcium ion. Calcium will enter through the calcium channel after the phosphorylation by CAM kinase. So this calcium will move from the outside to inside, and this calcium is responsible for the contraction of the heart. Now, DAG, the another secondary messenger is the DAG. DAG will stimulate the phosphokinase C enzyme, and when the phosphokinase C enzyme will stimulate, this is responsible for the further phosphorylation. So this will phosphorylate the enzyme and will be responsible for the alteration of the metabolism, and this will also phosphorylate the transcription factor and responsible for the alteration of the genomic expression. And now this time this will phosphorylate the potassium channel, and as you know, the intracellular potassium is more, so according to the diffusion law, the higher concentration of the potassium will move from the lower concentration of the potassium side. So this will move from the cell to the outside, and this will go to the hyperpolarized state. So the calmness will occur. Isn't it or not? Yes, thank you. Like this video, give us the thumbs up, and if you want to ask any questions, you can drop your questions in my comment box, and I will be happy for your questions.